Right, guys, today we are going to be talking about 5.3, which is trigonometric functions on the unit circle. And for a think and a warm up, we're just going to recall the six trig functions. We have sine of theta, cosine of theta, and tangent of theta. And then the reciprocals of those, we have cosecant of theta, secant of theta, and cotangent of theta. Remember, this reciprocal of sine is cosecant, the reciprocal of cosine is secant, which is a little messed up because they're backwards, but that's just how I remember it. I know I've just remembered that those two are kind of switched around. Yeah. So a unit circle is a circle with radius 1, right? When we talk like units, that's usually what it means, something of length 1. So this is 1, 1, -1, and -1 down here. And whose center is at the origin? I'll scroll down just a little bit so you can read this. So cosine of theta can be redefined as the x-coordinate, and sine of theta can be redefined as the y-coordinate. Now, why can we do that? So if we look at this unit circle, and we're looking at a point here, like some point with coordinates x and y. So that's all I'm saying, coordinates x and y. Now, if we take cosine of this theta in the middle here, what is cosine of theta, right? Cosine of theta, SOHCAHTOA, adjacent over hypotenuse. Well, adjacent is this length here, right? This x length. And the hypotenuse is just 1. So that would be x over 1 or just x, right? So that's why our x coordinate here, right? Because this is x out, and so is this, right? They're the same length. So that is why that works like that. And it's a similar thing for y. So if we take sine of theta, right? I'll do this one over here. If we do sine, I'll do it in a different color actually. If I do sine of theta, right? Well, what is sine? SOHCAHTOA, that is opposite over hypotenuse. Well, what's opposite? Opposite is this y value to this point, right? So that would be y, and then the hypotenuse is still, because we have a radius 1 circle, it's just 1. So in other words, sine theta equals y, which is why we can do that. So on a unit circle, you could just use cosine of theta for x and sine of theta for y. And it might be a little weird right now trying to think about it, but I think once we get into some examples, it'll start to click for you guys. So since there's exactly one point, pxy, for an angle on the unit circle, for an angle theta on the unit circle, the relations cosine of theta equals x and sine of theta equal y are functions of theta. We call them circular functions since they're defined using the unit circle. And all that's saying is since there is a single output for every input, it's a function. And it's just in relation to theta this time, the angle going around instead of x, right? And then here are the 6 trig functions defined using the unit circle. We already went over why sine is y and cosine is x. But now why is tangent of theta y over x? Well, if we go back real quick, tangent of theta is y over x, because what is tangent? Tangent is SOHCAHTOA, opposite over adjacent. What's opposite? Opposite is y, right? Tangent theta, opposite is y, and what's adjacent? Adjacent to this theta angle is x. So that's why we have y over x for that one, right? And now all these are just reciprocals, right? Cosecant of theta is the reciprocal of sine, so 1 over y. Same with secant, it'll be 1 over x because it's the reciprocal. And then cotangent is the reciprocal of tangent, so you flip them, x over y. And that's how we get all those. Now, for example 1, it says use the unit circle to find each value. So I'm just going to do a quick sketch of our unit circle. Doesn't have to be perfect. And we know a negative 180 degrees, we are taking an angle in standard position here, and we are rotating it out 180 degrees, and now we're going negative 180 degrees, and now we're going that way, right? Let me actually extend it a little bit. So take an angle here, and we're rotating it out. It's going that way. Okay. So that's our negative 180 degrees. And we want to find cosine of it, right? So we know this point on the circle, right? It's a circle with radius 1. Isn't that point going to be negative 1, 0? If this is x and y, right? Negative 1 on the left, and it's right on the x-axis, so that's negative 1, 0. And if that's our x and y, but we know cosine of theta is x, right? Are we starting to see this now? If cosine of theta equals x, then cosine of negative 180 degrees should just be this x value, right? Equals negative 1. So that's how we would use the unit circle there. Now, secant of 90. So again, let's just draw a unit circle. Quick little sketch of one. Again, doesn't have to be perfect as long as we know what everything's supposed to be. And 90 degrees, right? So let's get 90 degrees on here. We're in standard position this way, and then we're rotating 90 degrees right here. Well, and now what's the point right here, right? Now the point is 0, positive 1. And secant, which one does that go with? Secant goes with cosine, right? So first let's find cosine of 90. Well, wouldn't cosine of 90 be 0? And then cosine of 90 would be, well, and then secant of 90 is going to be the reciprocal of 0, right? What's the reciprocal of 0, right? That means that whatever we had, so if we have secant of 90, right? So let me write it like this first. So cosine of 90 would be x over 1 on the unit circle, right? And we have x to be 0, so 0 over 1, which is 0. So I think that's an important rewind. So secant of 90 would be the reciprocal, which is 1 over x, but x is 0, right? And that's the biggest, almost looks like a 6, I'll rewrite it. And that is the biggest no-no in math, right? Absolutely no dividing by 0. What happens when you divide by 0? Always, 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 it will be undefined, right? So if you're dividing by 0, it is going to be undefined. All right, example 2. If a football is punted from ground level, the maximum height it will reach is given by the formula h equals v naught squared times sine squared theta all over 2 times g, where v naught is the initial velocity, theta is the initial angle, and g is gravity. Suppose the initial velocity of the ball is 28 meters per second. Describe the possible maximum height of the ball, or height of the ball is the angle between 0 and 90 degrees. So what we're going to do here is that's a lot of words, but we're just going to use this, and we're just going to plug in what we know, right? So v naught, the initial velocity, gives us is 28 meters per second, so I'm just going to put 28 in there, and that's squared, and then times sine squared of between 0 degrees and 90 degrees, so let's do 0 degrees first, all over 2 times 9, that looks like a dot, don't want that, all over 2 times 9.8. Yeah, 9.8. That's all. Sine of 0, right? This is where you can use your unit circle, or you can just know what sine of 0 is. Sine of 0 is actually 0, right? So 0 times anything is going to be 0, and then 0 divided by anything is 0. So we're going to get 0 for that first one, right? And now we could do the same thing. We have 28 squared times sine squared times, and now our maximum is 90 degrees. So if we were to punt the ball straight up in the air somehow, all over 2 times 9.8. Now, you could punch this in your calculator, but sine of 90, what would sine of 90 be? So if we think of a unit circle, 90's here. Where's that point? 0, 1. Sine of 90 is 1, and 1 squared is just 1. So this is going to be 1. So all we have to do is take 28 squared and divide it by 2 times 9.8, and that will get us 40. And then we're in meters. So then you would say the maximum height of the ball would be 40 meters. And it makes sense that this first one's 0, right? If we put the ball at 0 degrees, it's going straight into the ground, right? It has no height. And otherwise, if we somehow manage to kick it straight up, that'll be its highest point. And we know it's the highest, right? Because if sine is always the y value, pay attention to the y values as we go up from 0 to 90, right? That's smaller than 1, that's smaller than 1, that's smaller than 1, that's smaller than 1, and that's 1. That's its greatest value, right? So we know that that'll be the maximum height of the ball. And that will end it for our first part of 5.3. The next one will get a little more involved with the unit circle.